Welcome, everyone. In lieu of playing you some music or elevator music, we decided to pick something kind of industry specific. So I hope you enjoyed it while you were waiting to join us today. Welcome, I'm Joan Engebretson. I'm the managing editor at Telecompetitor. And our topic today is Closing the Gap, Wi-Fi's quest to keep pace with wired connections. I also wanted to let you know that the webcast today is being recorded. Before we begin today's webinar, I'd like to recognize and thank our sponsor, Zyxel. Zyxel is a pioneer in IP technology for over 30 years. They provide a complete portfolio of end-to-end business networking solutions. The first choice of many tier 1 service providers and small and medium-sized businesses, Zyxel offers its partners service-rich solutions backed by domestic logistical, sales, and technical support teams based in Anaheim, California. Next slide, please. So our goals for today are to discuss deployment challenges, whole home Wi-Fi, Wi-Fi 6, 6E, and 7, the differences between them, the overviews and benefits. I'm really looking forward to that part. Manage Wi-Fi and the subscriber experience. I wanted to let attendees know that they can use the Q&A tool on your screen toolbar to enter questions at any time whenever they occur to you, although we will wait until the end to answer the questions. So here today with us is Andrew Cuellar, who is Product Marketing Manager for Zyxel. Andrew handles product line related marketing support nationwide and regional telecommunications. Andrew brings over a decade of experience and product knowledge from his time with Zyxel. He can speak across multiple networking topics, including fiber to the home, some people call it FTTX, XDSL, that includes VDSL and all those different versions of DSL. Ethernet, Wi-Fi, VoIP, IPTV, and TR069. Andrew, please take it away.
Thanks, Joan. I lost my video. Uh-oh. Oh, hello, everyone. Now I lost the presentation. Okay, there we go. All right. Sorry about that. All right. Thanks again, Joan, and we'll get started here. Like Joan mentioned, we're going to mainly be talking about Wi-Fi today. So we'll just get right into it here. Wi-Fi is the internet to most of our subscribers. They don't know the difference of how it's being delivered. They don't really care how it's being delivered either. They just want to make sure that the Wi-Fi is always on, always working. And it's become really the cornerstone of the home, of the smart home, really, and continues to be that way. But it has changed, especially the way we used it, coming out of, staying at home, working from home. The way that everyone uses the Wi-Fi has definitely changed, and it's expanded, especially with the IoT boom, having lots more devices connected, always on, from your light bulbs to your thermometers. Wi-Fi is in everything. So it's come a very long way from just, a handful of devices in the home to now being upwards of 30, 40 devices in the home, connecting and utilizing that Wi-Fi. And really the way that I mentioned that it's changed, people are moving around constantly now, a lot more mobile streaming occurring. So we've really changed the way that we use it, and it's evolving to keep up, to keep pace as we see more and more bandwidth offerings coming about. There's a lot of talk about 10G, a lot of service providers offering up to 8 gig service. So Wi-Fi is continually evolving to keep up, to handle these higher bandwidth speeds. There's more demand for Wi-Fi, really. And as you can see, it's come a very long way. From the old days with the rabbit ears, external antennas, and we've made changes now to everything internalized. So one less thing for the subscriber to sort of mess with that could impact the performance of the wireless. Along those same lines, we've also changed the name a bit. So we don't have to worry about the highly technical, 802.11 AX, AC. Now with Wi-Fi 7, 802.11 BE. So we've made things a little simpler there, just calling them Wi-Fi 4, 5, 6, 6E, and 7. And that's going to continue going forward as well as we continue to make improvements and changes and just better techniques in general to handle the various speeds and way that we utilize the Wi-Fi. But it's not perfect. So that's why we see this constant evolution of things progressing forward with changes, improvements. But there's a lot of variety of factors that could impact the performance, and it's not exact, but we're getting there. We're constantly working to make things better and make improvements so that eventually, in the future, hopefully we can say that we don't have to worry about a wired connection anymore. We just use the Wi-Fi for anything and everything that we need. With that, if you could queue up the first poll, please. Okay, so just a quick poll here. How common are support requests related to Wi-Fi? The first option, very common. Most of our trouble calls are related to Wi-Fi. Second option, some of our trouble calls are related to Wi-Fi. The third option, none or very few trouble calls are related to Wi-Fi. And then the final one is none. That simply don't offer to manage the Wi-Fi for subscribers. So if you could take a moment and select one of the options here, just to get an idea of where we're at. In general, I feel like, when it comes to a lot of support requests, Wi-Fi is pretty commonly a bit of an issue, whether it's coverage or speed. There always seems to be some type of issue there. Okay, so that's a pretty interesting spread there. Some of the troubles are related to Wi-Fi. So really, I just want to get an idea of where the audience is at. Like I mentioned, it's not perfect, but it's getting there. We're working our way up to that. So along the lines with some of the challenges we face when deploying Wi-Fi is that not all devices are the same. There's sometimes limiting factors. Some devices have more antennas than others. With our phones, our mobile phones, our tablets, sometimes it's easier to have more antennas in there, but not everything is the same. So, and the lifespan of these devices is also extending as well. So we're seeing that, that I guess we can call them legacy devices still being used in the home. If it's not broken, don't fix it, right? So there's a lot of things that, as we move forward with Wi-Fi technology, sometimes you have to get a new device to keep up, really. Even though your old device may be working, it might have a limiting factor here where it can't get a better performance as you upgrade your wireless technology. And of course, one of the biggest challenges is coverage, covering the entire home, blanketing the entire home. And that's where we get the term, whole home Wi-Fi. And then off of that, we have managed Wi-Fi. But of course, coverage is always a bit of an issue. Now we're seeing more outdoor Wi-Fi come about where people want to blanket not only their home, but their detached garage, workshop, sometimes even a pool area, to be able to utilize the Wi-Fi, again, any and everywhere they can. And along with challenges coverage, that's where we get into things like mesh, easy mesh, and adding extenders, pods, whatever the case may be. But not only are there challenges with coverage, sometimes there's things that simply get in the way. Just like there's not there's a variety of devices on the market. There's a variety of different home builds, different obstacles that may be in the way. I mean, large appliances that may interfere with Wi-Fi. and even what the homes are built with. So we've seen something like this in the past before, chicken wire kind of being in the walls of the home, which is essentially kind of trapping that Wi-Fi signal in, really interfering and causing an issue with coverage. But there are a variety of different, again, building materials. This a quick breakdown here of some of the obstacles and their impact on the wireless signal. So the typical building materials, have very little impact. We can generally break through those with a wireless signal. But as you go down the list, there's a higher impact, and even us, our bodies, since we're mostly water, interfere with the Wi-Fi. So we've seen where simply using like a wireless test meter, standing between it and the wireless router does impact the signal strength. It's pretty interesting to see. Um, so if you have a large gathering at your home and Wi-Fi might be impacted, with all of the people sort of absorbing that signal. And then down towards the bottom, obviously things like water. Looks like water, metals, mirrors, they definitely I'm sorry, I got distracted here by the chat message. So about materials obstructions in 2.4, 5, and 6. Um, there's 2.4 generally does break through most anything. That's one of the main reasons it's still around, is because of its capability to cover a large area and go through most objects pretty seamlessly. Um, but when we get to the 5 GHz and then definitely with the 6 GHz, there is a larger impact with these obstacles. Um, so generally, it's definitely going to create an impact when it comes to coverage on the 5 and 6 GHz. Thank you, Joan. I will ignore those messages. All right. Uh, so the placement of the gateway, very key important when deploying Wi-Fi. Typically you'd want something central to really blanket umbrella those wireless signals out to cover the entire home. Up high, we don't want them under desks, on the floor. And of course, we want to avoid large major appliances that could impact the wireless performance. You don't want it installed above a washer machine, laundry area, things like that. But sometimes we're stuck installing a device where the subscriber wants it, where they expect it to be, entertainment center, things like that. May not always be the most ideal location to cover the entire area, but that's where we have mesh and being able to deploy extenders to extend that coverage, things like that. And brings us into the next topic to really talk about the coverage and concerns there. Do we need just one router? Will one router work? Do we need to add additional extenders? Not everything's the same. Not every deployment's the same, unfortunately. So there's always a variety there. But when we talk about mesh, it brings a lot of features that really help improve things for the subscriber, for their experience. You have that seamless transition between extender and router. So if you're moving about the home, you can make that seamless transition so you don't have a hard drop, things like that. And that's where we get into a lot of airtime techniques. So in terms of Wi-Fi along with mesh, there's been a lot of work put into not only finding out information about the clients attached to the wireless, but also the airspace around it. So we're collecting a lot of data and making decisions now on the device itself. So it's not like we have to manually move clients around. It's being done on the fly instantaneously. There's a lot of backend information that's being collected and making these decisions to overall improve the experience. So when we talk about extending the coverage, typically a high-powered router covers about a 2,000 square foot space. And that's where we want to look into adding more extenders as we go to larger coverage areas. And one of the nice things with Wi-Fi 6 and Easy Mesh is, we no longer have to worry about uh, placement necessarily with mesh units, because now the systems are intelligent enough to find the best route out. So in the past, we had to have sort of a hub and spoke where every extender had to connect back to the primary router, where now, we can daisy chain these and we'll find the best path out to, again, the best experience for that wireless device. Okay. So with Wi-Fi, managed Wi-Fi, here's where we get again that whole home coverage. So we have that single SSID, that single network name that can cover everything needed. Oh, sorry. Oh, getting ahead of myself. Okay. So along with that same SSID, we have just that one network that can connect all the clients. So the 2.4, 5, and now 6 gigahertz with Wi-Fi 6E and 7 that can have the same network name. So, the system can decide where to place clients. If they can support the 6 gigahertz, they can connect to that one connection and kind of move about as necessary as they, you know, walk out of the 6 gigahertz bubble to the 5 gigahertz and then to the 2.4. You have that seamless transition. Um, Along with mesh, we get the load balancing, AP steering, band steering, roaming. There's a lot of features that come along with mesh to really improve the experience for the wireless clients. Okay, I believe here should be the second poll, if we could cue that up. Okay, so before I get into a bit of the wireless topics, specific Wi-Fi 6, 6E, 7, a quick poll here. Which Wi-Fi technology do you offer your subscribers? The first one, we are currently deploying a Wi-Fi 6 solution. The second one, we are looking to deploy either Wi-Fi 6E or 7 solution. The third option, we are currently deploying a Wi-Fi 5 solution. And then the final one, none. Subscribers bring their own gateway. So if you could take a moment, just select one of these items. Just more of a general curiosity here to see, where everyone's kind of at. Okay. So, I mean, we are currently deploying a Wi-Fi 6 solution, seems to be kind of the biggest one. And Wi-Fi 6, for what it offers and the big changes it made from the previous generation Wi-Fi 5, it's it's a huge improvement. And that's some of what I'll talk about now is what Wi-Fi 6 brings us. And we'll get into some of those details here. So with Wi-Fi 6 compared to Wi-Fi 5, its predecessor, we have a definite increase in bandwidth, up to 4 times faster than the previous generation Wi-Fi 5. One of the biggest ones now is more connected devices, being able to handle all of these wireless clients, especially the ones that are, not necessarily using a lot of bandwidth, but they're always on, always connected. Something we're seeing a lot with IoT devices. Um, they're always on, always connect, always sending something, but it's not a whole lot of traffic. But using a piece of that bandwidth, using a piece of the pie of the wireless. With Wi-Fi 6, we also have improvements in latency and then some airtime techniques to really improve the usage really for all of the connected devices. I think that's really important there is Wi-Fi 6 offers benefits, of course, to Wi-Fi 6 clients, but it also maintains and doesn't leave out, let's say, the legacy clients that are connected. And yeah. And finally, one of the other items that it does bring is improved battery life. So if you have a Wi-Fi 6 client connected to your Wi-Fi 6 gateway, there is some pre-negotiated time where, it tries to not send as much information to, because when you're actively sending information using the antennas on your phone, or your mobile device, it's utilizing the battery. So with Wi-Fi 6, we're really trying to improve that. So if we don't need to send information, we won't send information, things like that. And I'll get into a little bit more of a breakdown in these in a few more slides. But before that, Wi-Fi 6, also Wi-Fi 6E, still Wi-Fi 6, still both Wi-Fi 6. It gets a little, I guess, confusing, I guess you could say. 6E, the E is for extended. We're extending into the 6 gigahertz spectrum. So with Wi-Fi 6, we have the traditional 5 gigahertz and 2.4 gigahertz. But the 2.4 obviously is heavily impacted, lots of interference. 5 gigahertz is also getting to that same level. So with Wi-Fi 6E, we're opening up a new spectrum, sort of greenfield to deploy and really take advantage of. Really offloading a lot of the duty with Wi-Fi 6 and the 5 gigahertz, because typically when you set up mesh with a dual band router, that 5 gigahertz is doing double duty. So it's operating as handling the wireless clients, but also as a backhaul to the extenders. So Wi-Fi 6E is really giving us another whole spectrum to work with to combat congestion, interference, things like that. And here's a breakdown of the wireless spectrum, the 2.4, 5, and 6 gigahertz. So obviously with 2.4, we don't have a whole lot to work with, but it is what it is. It's still necessary. It's going to be necessary. I don't feel that it's going to go away for it's going to be around, I want to say forever, the 2.4, simply because what we can do with it and the coverage that it offers. You see, we moved down to the 5 gigahertz, and we do have those wider channels. We're getting wider, more channels available, but we're still seeing congestion now arise on the 5 gigahertz, especially MDU apartment complexes, a lot of battling there. But then when we move down to the 6 gigahertz, we have even wider channels and more channels to work with. So wider channels, more availability. The wider channels obviously offering even more bandwidth, throughput capability with 6 gigahertz. And we see that improve as well with Wi-Fi 7. So just a quick side-by-side, the key differences, Wi-Fi 6 and 6E. Like I mentioned, more channels, wider channels, and the big thing obviously is 6 gigahertz. There is a bullet point there, explaining that it's not backwards compatible with earlier Wi-Fi standards. I wouldn't say backwards compatible. It's really, when it comes down to it, more of a hardware limitation, because our current mobile devices, PCs, laptops, simply don't have a 6 gigahertz radio. So that's why, we're seeing new devices come out now with Wi-Fi 6E support and Wi-Fi 7 support as well. So being able to communicate on the 2.4, 5, and now 6 gigahertz. So fortunately for, our mobile phones, tablets, we need to move on to the next generation in order to take advantage of the 6 gigahertz spectrum. But for the most part, we are seeing a lot of the 6E being utilized for, specifically the 6 gigahertz being utilized as a wireless backhaul, again, to offload that 5 gigahertz so it can focus on the existing wireless clients. So with Wi-Fi 6E, now we have true tri-band routers, where 3 completely separate radios communicating on different spectrums. In the past, we did see some devices come to market where they offered two separate 5 GHz radios, one, specifically for backhaul and one to focus on the wireless clients. But now with Wi-Fi 6E, we have that true capability of 3 completely different spectrums, 3 separate radios on the router. So Wi-Fi 6E, 6 GHz specifically, takes us into the next step. Really, what I kind of see it as is a stepping stone. 6E is getting us ready for Wi-Fi 7, which utilizes that 6 GHz spectrum a bit more. But with 6E, we do get up to gigabit speeds on the wireless. Very impressive. I don't know what we're doing with it, but it is capable of achieving that with, a mobile phone. But some of the other key benefits, obviously improvements in latency, because it is that brand new spectrum. There's not a whole lot operating, utilizing it, especially in the home, and higher capacity to handle more clients. So, like I mentioned before, we have those wider channels that are really pumping traffic through there. So a bit more on the backwards compatibility. Wi-Fi 6, 6E, it does, I feel it does provide somewhat of a benefit to the legacy Wi-Fi 4 and 5 clients, because the network is no longer being brought down. In the past, with legacy Wi-Fi 4, 5, when an old device would come on board, it would kind of bring down the entire network to operate at its level. Whereas now with Wi-Fi 6, 6E, it can handle those slow clients and those fast, brand new clients, no problem. So there's no real impact if you do have an older device. And, this is extremely important nowadays, that all of the IoT devices, they're using, in some cases, Wi-Fi 4, wireless N sometimes, because those chips are still around and they're very cost effective. And a lot of these devices don't need a lot of bandwidth. So again, Wi-Fi 6, 6E, one of the big benefits, maintaining that network, the experience across the board for all wireless connected devices. But again, with 6 GHz, you do need to have that 6 GHz support on the client in order to communicate with it properly. So side by side, Wi-Fi 5, 6, 6E router, if you have a single client, not a whole lot of improvement. There's not a whole big difference there, I'd say. But where you really start to see the difference is when you add all of your wireless clients, all of your network devices, get those connected, and that's where you really start to see improvements for Wi-Fi 6. Wi-Fi 6 was really about efficiency, really trying to maintain the experience, let's say, for all of the connected devices. Okay, so real quick, some of the technology, the back-end technology. I won't spend too much time here. It's not crucial to know, but it's nice to know, to have an idea of, what's going on in the background, what these improvements are actually doing. Okay. So on the top left, MU-MIMO, multi-user, they all have very technical names. But we'd like to simplify. So MU-MIMO, in the past, Wi-Fi 5, when this first started being introduced, it was about communicating with multiple clients at the same time. So with Wi-Fi 5, we were able to do that up to 4. So up to 4 clients the router can communicate with up to 4 clients at the same time, and only in one direction. So we built upon that with Wi-Fi 6. Now it's in both directions, so send and receive to those clients. And I believe it's up to 128 active lines of communication that we can have at the same time. So handling a lot more clients, all goes back to efficiency. On the top right, OFDMA. We did make some improvements with the previous generation, but with Wi-Fi 6, you see the planes there. Again, about efficiency. So instead of sending three separate streams, we're able to compact those, think of like a jumbo jet, kind of compact that traffic so that it is delivered more efficiently. Down in the lower left, we call QAM. Not only used in Wi-Fi, it was something used in, or is still actively used, DSL. But the idea here is we're adding more lanes to the highway. We're making those lanes high so that we can fit more traffic in. That's where we see the higher bandwidth, those higher throughput rates. And then finally, on the bottom right, beamforming, or in this case, active beamforming, with Wi-Fi 6, 6E7. Improvements there to really not waste time. In the past, it was more of a broadcast that would have to be set out with previous generation Wi-Fi, where we'd have to kind of announce and try to find a specific client to send them what we need to send them. Whereas now with Wi-Fi 6, we're able to actively track all of those clients. So we're not wasting that airspace, wasting that time trying to find where these clients are. We know exactly where everyone is and can deliver everything more efficiently. So again, Wi-Fi 6, all about efficiency. Okay, so before we move on, it's Wi-Fi 6, just a general idea of what 6 gigahertz really brings. Throughput, it's a pretty dramatic, well, not necessarily dramatic. It's a noticeable increase when you're able to communicate with a Wi-Fi 6E client. The throughput is definitely improved. And we also see the latency go down there as well. The range isn't quite there yet, but that should change in the future. But yeah, just give you a general idea of what we're seeing with Wi-Fi 6E. Over gig speeds with a single client, definitely impressive. And it's only increasing the capability from there. All right. So, like I mentioned, Wi-Fi 6E is really the stepping stone into Wi-Fi 7, which is now certified. The certification came down in January this year. So Wi-Fi 7 is here. It took us a while to get to Wi-Fi 6, and Wi-Fi 6 has been a huge improvement from previous generation Wi-Fi. And now we're up to Wi-Fi 7. The goal with Wi-Fi 7, ultra high throughput, I believe it's referred to. And that is really what it comes down to with Wi-Fi 7, is going beyond, theoretically up to 40 gigs over Wi-Fi. In some testing, we've seen a Wi-Fi 7 client be able to achieve up to 3 gigs, which again, very impressive, the way things are going there. But anyways, side-by-side comparison here of Wi-Fi 6E and Wi-Fi 7. So just like those back-end improvements, so we're not only improving bandwidth, we're able to utilize some wider channels. Wi-Fi 7, I want to say maybe the most talked about feature, MLO, multi-link operation. I have another slide breakdown of that, but one of the biggest features that a lot of people are looking forward to once we get the market shifts to have more Wi-Fi 7 devices on the market, we may see some people try to take advantage of these new features. All right. So another breakdown of the channel, sorry, the spectrums, 2.45 and 6 gigahertz. With Wi-Fi 7, 2.4 and 5 gigahertz are unchanged. But when we go down to the 6 gigahertz, that's where we see a change with from Wi-Fi 6E to Wi-Fi 7 is even wider channels. So going from 160 megahertz up to 320 megahertz. And that's where we're seeing those increase in throughput as well, because of those wider channels on the 6 gigahertz spectrum. So like I mentioned, one of the biggest features, biggest improvements, or changes really, with Wi-Fi 7 is multi-link operation. So obviously with Wi-Fi 6, we have a single link where you communicate on either the 2.4 or 5 gigahertz. Now with Wi-Fi 7, multi-link, we're able to combine all three bands into one large pipe, one to even, that's where we're seeing even more and more bandwidth capability there. And there are some service providers, like I mentioned, already offering up to 8 gig service. And this is one of the ways that, we'd be able to take advantage of all of that bandwidth in one go with multi-link operation. 2.4 gigahertz doesn't really add a whole lot in terms of throughput, but the 5 and 6 gigahertz definitely put you over the top there. And I think we're talking 7, 8, 9 gigs up to around there, pretty consistently using multi-link operation. And that's the question. What should I do? What do we do? Do we go with Wi-Fi 6, 6E, 7? Do we wait for what's next? When it comes to especially what we've seen with Wi-Fi 6E, the adoption rate wasn't too quick. But now that Wi-Fi 7 is here, we might see a bit of an uptake, especially in those trying to utilize the 6 gigahertz spectrum. There are some limiting factors, some situations that certain providers aren't quite pleased with when utilizing the 6 gigahertz spectrum. But that's when we get into managing Wi-Fi and not having them pick a device off the shelf that could potentially cause some impact to other items in the network. Having the ability to control, make changes, and yeah, make changes to do what you need to do. Having that management option is very key. But when it comes to which technology to pick, there's no easy answer. I feel like we're always going to have certain subscribers that want that bleeding edge, that cutting edge technology. Yeah, just no easy answer. Wi-Fi 6 is still great. It's having lasting impact, let's say, and what it's done in terms of reliability and efficiency, of course. So yeah, there's no easy answer there, but I hope now at least going over some of the Wi-Fi technologies that we have a better idea of what we can offer in the different areas. All right, and then of course, will any router do? I mean, of course, it'll get you online, but as service providers, you want to have some type of control, some insight into the network. And that's where the off-the-shelf routers really kind of fall short, not having those options. And that's where we get into managing Wi-Fi, managing the opportunity, and assisting your customers. The nice thing with Wi-Fi technology, oh, I don't know about nice, but when we talk about the 6 GHz spectrum, Wi-Fi 6E, Wi-Fi 7, it's still Wi-Fi. So I don't want to put it in a negative light, but we're still going to have the same struggles that we do now with Wi-Fi 5 and 6, especially when it comes to educating our customers. There's still going to be a bit of a struggle there, but in terms of actual support, it's going to be pretty much the same because we're still using the same SSID password. Not a whole lot is changing there, other than the wireless security advancing as well. But with 6E and 7, hopefully we're combating a bit of that interference, congestion, things like that. So just keeping moving forward. And when it comes to supporting our customers, like I mentioned, it's still the same routine maintenance, onboarding new devices. They may have forgotten a password. So being able to do that instantly, remotely, is a definite plus. And that's where obviously managed Wi-Fi plays an important role with routine maintenance, upgrades, and cost saving for the service provider. Not having to go on site, being able to troubleshoot remotely is very important. And it's going to continue to be as we offer more bandwidth, higher bandwidth tiers, new Wi-Fi offerings, still going to play a key role in supporting your subscribers. And along those lines, we have the industry standard for remote management, TR069, utilizing an ACS. Everything is kind of, I think, offloaded. Everything's kind of being offloaded to the cloud now. So there's a lot more talk about, cloud servers. In the long run, helping the cost save, because you don't have to maintain those servers locally. But obviously there is cost involved. But everything is kind of making that transition to being in the cloud. But this is still one of the best ways to manage and support your subscribers, gain some useful insight into what they may be, if they're maxing out their bandwidth, if they're if there's an opportunity to upsell, things like that. So on that same note, like I mentioned, everything's being offloaded to the cloud, but we're also seeing that emergence of some open source management platforms. Again, to try to get as much as we can, as much information out of our subscribers so that we can upsell, things like that, and of course support them as needed. Just more alternates, really, and improving the communication. So it's getting more efficient there on the back end, being able to communicate, make changes, do what you need to do quickly and efficiently. And that's where we're also seeing, on the industry standard side, trying to keep up, trying to maintain and evolve along with Wi-Fi and more bandwidth to TR369. User services platform. We still have the same capability with TR069. We're just making those improvements, making communication faster, more reliable, more efficient. We can have more controllers. There's a lot of things happening on that side of things with the industry standard TR369 to improve the way we support our subscribers. So yeah. That is my final slide. Before we get to the Q&A, We would like to mention that we will be raffling off our Wi-Fi 6E gateway, our EX7710, to one of the attendees. It does feature a 10 gig WAN and LAN port. So we have a non-blocking design, and it is the first 10G OpenSync router in the industry. And with that, I believe I'll hand it back to Joan.
Thanks, Andrew. I learned a lot on that. Appreciate you going through all the technology with us. And we have quite a few questions queued up. I did want to remind people, if you have not yet asked a question and would like to do so, please use that Q&A button and type your question in there, and hopefully we'll get to all of them. So I'm going to start with some of the ones that have been here for a while. How will Wi-Fi support the FCC requirement to provide universal internet access of 100 megabits per second?
Nope. That's interesting.
I think they're talking
Typically,
about matching the speed inside the home. You know what? I guess they're kind of saying maybe it's not enough to have 100 meg to the home. You have to get it throughout the home. I mean, that's how I'm interpreting that one.
yes, I agree with you there. I feel like a lot of wireless clients are already capable of doing that, especially when we talk Wi-Fi 6. 6E and 7 are already going beyond that. But typically when we talk about the FCC requirement, I don't believe it talks about going beyond the router into the home, right? It's a test that is run to the gateway, or from the gateway, you could say. So that doesn't really go hand in hand with the Wi-Fi. I mean, Wi-Fi 6 again is capable of it, definitely 100 megabits per second. But typically that test is done to the gateway and doesn't really have anything to do with the Wi-Fi.
Yeah. I think it is an interesting point, though, that people might think that they should get it, you know, all the way to their desktop. And if they don't have the right Wi-Fi, maybe they won't get it, even though their service provider's delivering, you know, what they're supposed to do. So, and
Absolutely.
you also raised an interesting question about the multi-gig speeds, you know, that that's going to be even more of a challenge to make sure that it doesn't just go to the house, but goes throughout the home. And it sounds like some of these more recent versions of Wi-Fi, you know, really help out on that regard.
Definitely.
Another question is, what is the range of Wi-Fi 6 and 6E?
Well, in an ideal location, no, we typically say the 2,000 square foot range for Wi-Fi 6. 6E doesn't really add on to that, make any improvements. We're kind of set in our, or limited in our output power in some cases. As if I'm sure some people wouldn't mind really putting some wattage out there and really amplifying those radios. But it's still where we're at now with a typical router, Wi-Fi 6 or 6E. We're still in that 2,000 square foot range of coverage. 6E, 6 gigahertz specifically, doesn't add anything extra, and it's actually a bit smaller than the 5 gigahertz in terms of coverage.
Okay. There is a question, can you please speak to materials obstruction relating to the frequency band? I guess they're asking, do you get different levels of material obstruction, you know, if you're using 2.4 versus 5 versus 6 gigahertz? I think that's what they're asking there.
Okay. I want to say 5 and 6 is kind of on the same level. 2.4 is the one that really breaks through a lot of materials, whereas the 5 and 6 gigahertz may be more impacted. Yeah.
That makes sense. And then there's another, there's just a comment here. Insulation is also a medium to high obstacle severity. That was a comment made when you were showing all the different things that can impact.
No, I could add that in.
Yeah. Great suggestion from the audience. And then there's another one here. Please elaborate on how Wi-Fi 6 is backwards compatible, but Wi-Fi 6E is not. What does that mean for an order? I think they mean older Wi-Fi technology device in the home.
That's where I I wish we called it something different, Wi-Fi 6E, since it does get a little confusing because it's still Wi-Fi 6. But when we talk about the backwards compatibility, um, Wi-Fi 6E and the 6 gigahertz specifically. So only that 6 gigahertz spectrum is the one that is not backwards compatible. Again, because we simply don't have 6 gigahertz radios in our everyday devices yet. So that should change in the future, as we move forward and more devices come to market with that 6 gigahertz radio built in. But, legacy clients will still be able to use or connect to a Wi-Fi 6E router on the 2.4 or 5 gigahertz band.
That makes sense. And then there's a question, by the way, I will mention again to the audience, if you'd like to ask a question, please type it into that Q&A button on your screen and we'll get to it. I think we have one or two more queued up here. There's a question about TR-369. Will this allow for speed and latency testing on extenders using TR-369?
So if we move to 369, that is an interesting question. So we want to check the speed and latency to the extenders. That is something I will need to look into. I can definitely get back to you on that.
Yeah, we have the contact name for people that are trying to.
All right.
And then there's another comment, just spray foam mainly is a bad impact. I think they're talking again about, potential obstructions in the home. And so I have a question or two. One is that, you talked about how there's different range for the different frequency bands. But then also with 6E, with 7, you have the ability to combine multiple bands, to get wider channels. Is it then, does the band with the least range become kind of like the least common denominator there? I mean, how much range do you get when some of the frequency bands can go far and some of them can't go so far?
Yes, yeah, you're exactly right. I mean, that's going to be the limiting factor is the range of a specific band or, the distance that it's carrying. But MLO, combining them doesn't improve the coverage, let's say. It's still limited by those radios.
I'm going to make another reach out to the audience. If you'd like to ask a question, please type it into the Q&A button. We still have time for one or two more, I think. If nothing else is coming in from the audience, I will ask a question. Will there be any shortages of Wi-Fi 7 equipment? Since it's new to the market and there's pretty big demand for it, or do you think manufacturers will be able to meet the demand from the get-go?
I think there's a bit of hesitation, when it comes to rolling it out too quickly, let's say. I don't think there's going to be any manufacturing limitations, but I think there may be concern about adoption because we saw Wi-Fi 6E kind of take a while to really attract devices, clients, wireless clients specifically. But now that we've made that transition to actually including 6 gigahertz radios into these devices, it should be a better transition to Wi-Fi 7. But we're anticipating that there are devices already on the market with Wi-Fi 7 off the shelf, especially. But the clients are a bit behind. So it's going to take some time.
Yeah. Do you know off the top of your head about how likely it is that a mobile phone would have the 6 gigahertz capability or the ability to use all this? Is that something you've looked at? I don't know if you have or not.
Yeah. We had to source some Wi-Fi 7 phones as well. So there are some available. The iPhone 15 Pro Max, the top of the line iPhone, offers 6E support now. And that's usually kind of, don't like to say it, but Apple is kind of the trendsetter. So, once they installed that or went with 6E, more are likely to follow. But we're seeing flagship phones from Google, Asus, Wi-Fi 7 capability already. On the Android side, it's a bit quicker, given the capability there.
Another question came in from the audience. This is a good one too. What is the general price difference between Wi-Fi 6E and Wi-Fi 7?
Oh, I have no idea. I'm in marketing. Um, I don't believe it's too much of an increase. I mean, there obviously is going to be an increase with the new chips. Um, but it's not as impactful as I think people anticipated. Um, we'll see. I mean, if you buy enough, it should be cheap, right?
Yeah. I have one more question too. I know the FCC initially opened the 6 GHz band primarily for indoor use at certain power levels. I don't remember all the details, but I think they expanded how you can use it. What's the latest on that?
So yes, it is rated now for low power indoor.
Mhm.
But that is evolving as well. We are Well, the industry is working to address this with AFC, auto frequency coordination.
Mhm.
So if there is any potential interference, we can mitigate that quickly. But there's a lot of new requirements in order to get this to work properly. And we're just not quite there yet.
Mhm.
There's But it's coming. It's coming. It's something that is being developed, that is being worked on by several. Even the Wi-Fi Alliance launched their own team to kind of address this, so that eventually we can go full power.
Okay. Well, we are out of audience questions and it is just about time. We've just about used all of our time. So I'm going to say thank you to Andrew. I really learned a lot today. Thank you to everyone who logged in. And one of the questions we always get is, we'll be able to get a copy of the slides. Yes. And the archive of the webinar also will be on our website. So again, thank you all so much. And thank you, Andrew.
Thank you.